Hi everybody, it's Michael from scratchcats.org and Seattle CoderDojo. And this is the third video in the series that I'm recording to put on the scratchcats.org website. And this time I'm going to show you the maze game, which is here in this first section again. And in this game, the idea is that we draw a maze and then we let a sprite move through the maze that the player can use the arrow keys to move the sprite through the maze. So for this project, on the web page, on the scratchcats.org web page, it actually doesn't give you the code on there. So remember, with the basic racer project here, it actually told you exactly what code to write. This one doesn't show you the code, but I'm going to show you the code in this video. So hopefully between the video and the web page, you'll be able to make the project work. And what you might want to do is, after watching the video, just try to follow the instructions on the web page without looking at the video and see if you can remember how to write the code. And if not, you can look back at the video to see how to do it. Okay, so the way we're going to do this project, we start like before, where we click on Scratch to open up Scratch. And again, you want to make sure that you either have a Scratch account or you create a new Scratch account so you can save your project. And we're going to go into Create a New Project. And in this case, what we want to do is draw the maze on the background. So this is similar to last time when we drew the racetrack on the background. We're going to draw the maze on the background and use the colors of the maze to keep the cat from, going through the walls. So I click on the stage again over here on the right side of the screen, and then I can go to the backdrop section, and I can just use this first empty backdrop to go ahead and draw the maze. So to do that, we want to choose, again, like we did in the last project, we're going to choose this red slash to mean no outline color. And then for the fill, we can choose whatever color we want, but I'll go ahead and just leave that purple color that's already chosen. And then I'm going to choose this rectangle tool. And I'm going to make the maze by drawing a bunch of rectangles like this, and then moving them around with the arrow keys, sort of like this, to draw like a wall. And then here I'll draw another one that's kind of like this, with a little opening sort of for the sprite to start. And I'll just keep drawing them like that to make the whole border around the maze. And one thing, while you're doing this, don't worry too much about making it perfect. The one that's on the in the picture is actually a little bit misleading because it's so perfectly drawn, and actually it'd be very hard for you to draw a maze that looks quite this good with all the spacing exactly right and everything. So don't worry too much if your maze is like that. Just do your best to make a nice kind of maze. And the other thing is, don't worry too much about making it like a real maze that's actually hard to solve, at least at first, because it'll take you a long time to do that. And instead, let's just make, or at least I'm going to make a real simple one that just like has a wall right here and has a wall over here, and then maybe has a wall down here or something like that. So it's not really like a maze. It's just sort of like enough that we can write the program and we can go back and make the maze more interesting later. Okay, so that's the backdrop, and then I'm going to click on the cat sprite. And in this game, I'll go ahead and just use the cat, the default cat that it starts you with right here, and I'll go to its code. And we're going to start like we did the other project, where we're going to say when the green flag is clicked, because that's what's going to start the game. And I'm going to make it big like that, so the code is visible. And then we're going to want to change the cat size again, just like we did in the previous game, to make it smaller, because this cat, of course, is too big to go through the maze. So let me go ahead and go to the looks here and set size to, and we can try different numbers. I can try 30% and click on that, and that seems pretty good, but it's a little bit tight, so maybe I'm going to try 25% for the cat size. Okay, so the cat's going to start at 25%, so I'm going to set that. Remember our initialization code that we do at the start of the program. I'm going to set that up. And then I'm going to do the same thing we did before, where I want the cat to start in a certain position. And so what I'll do is I'll drag the cat to that position where I want it to start. And then I will go here, and it's updated the numbers on the go to XY block. And so those numbers right there, the -229 and the 0, are the right numbers to position the cat right there. So remember again, now if the cat is way over here, when I click the green flag, it'll set the size and go to that position. So I'll do it like that. Okay, so now we want to make it so that the player can move the cat through the maze. Okay, and we're going to try to use the arrow keys up and down and left and right, the arrow keys, to make the cat move. Now, one thing I said in the last two videos, which is that every game, I said, really has some initialization code like this, and then it also has a forever loop, which sits in a loop and waits for the player to do certain things and reacts to those things that the player does. So I said that every game has a forever loop. In this game, we're actually not going to use a forever loop. So this is an exception, but I'm going to explain why, and I'm going to explain why actually, to make this game maybe a little better, we could use a forever loop. Okay, so I'll do it without a forever loop first, and then we can talk about how it relates to the forever loop. Okay, so we want to make the cat react to the keystrokes. And last time when we did the keystrokes, when we wanted the cat to be able to turn left and right around our racetrack, it was based on this sensing, and we used this key pressed block right here in the blue sensing category. So we said, when the such and such key is pressed, like we said, when the right arrow is pressed, then we turn to the right. In this game, we're going to use a different mechanism, which is based on the event section, and we're going to just bring out this block and say when this key is pressed. Okay, and so for instance, I'm going to say when the right arrow is pressed, and we're going to react to that by moving the cat to the right. So I'm going to explain a little bit about the differences between when you might want to use the when a key is pressed versus this other thing, which sounds very similar, key right arrow pressed. So they're very similar, but they have kind of a different effect. And of course, the key right arrow pressed usually occurs inside of an if. So it would be in something that says, if the key right arrow is pressed, then do something. All right, so that's the way we did it before, and the way we're doing it now is when the right arrow is pressed, do something. Okay, so then the question is, what is it that we want to do? So here's another difference from the previous project. With the previous project, we used the move statement to move the cat. And it turns out that for the right arrow, as long as the cat is facing this way, as long as the cat is facing to the right, it would work to move 10 steps as I click this. So every time I click it, you can see the cat moves a little bit to the right, and here it is again, and the cat moves a little bit to the right every time I click it. But that's only because the cat is facing in that direction. And it's not so easy to move the cat either backwards in the other direction, or especially to move it down and up. We'd have to actually make the cat turn using a block like this, like we'd say turn, 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 and then start moving. So the cat is now facing in that direction. Now we could do the game like that if we wanted, but for this particular game, I just want the cat to always stay in its regular upright position, and so I don't want to turn it. And because of that, I don't really want to use the move way of moving. I don't want to say move 10 steps. So instead, I want to use this other way, which is to say we can change the X by or change the Y by. Okay, so it's a different way of moving. And a way to understand how it's moving is I'm going to go to the backdrop again, and I'm going to add one more backdrop. Scratch has a built-in backdrop down at the bottom called the XY grid. And so I'm going to choose the XY grid. And this backdrop is useful to see how the x and y coordinates work. So we see in the middle, x is 0 and y is 0. And then we see that x is the name for what's called the horizontal axis, and that means how far across the screen you are. And so as we go across the screen to the right like this, x goes up to 240, and we see that number right there, 240. And then as we go across the screen to the left, x goes down to negative 240. And we talked a little bit about positive and negative numbers, but basically the way it works is you count up when you're going this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 240. And then when you're going in this direction, you count negative. So negative 1, negative 2, negative 3, all the way to negative 240. And then similarly with the y, when you're going up, you count 1, 2, 3, 4, 5, all the way up to 180. And then when you're going down, you start here and you count down negative, negative 1, negative 2, negative 3, down to negative 180. So, I tell people a lot that you don't really need to know a lot of math to write a lot of kinds of computer programs, but one thing that comes up a lot is negative numbers. Whether you're writing a game or other kinds of programs, negative numbers seem to come up a lot. So we'll talk about those and use them. Okay, so the question is, when the user presses the right arrow, when the player presses the right arrow, what happens? Do we want to change the x or do we want to change the y? Well, since the x is the one that's about going side to side, we want to change the x. And then the question is, do we want to make the x bigger or do we want to make the x smaller? Well, x gets bigger as you go this way up to 240. So we want to make the x bigger. No matter where the cat is, increasing the x, adding to the x, will make the cat move to the right. So let's go ahead and just put this right in there, change x by 10, just like that. All right. And then to do one of the, well, since we did the right arrow, let's go ahead and do the left arrow. So let's click on events again and say when the left arrow is pressed, okay? And now instead of changing x by 10, we want the cat to move to the left this time. So to do that, I'm going to right click on this block, which you can also do shift click on the Macintosh. So either right click or sometimes shift click is the way to do it. And I'm going to duplicate this block and put it here. So the question is, with the left arrow, how do we want to change the x in that case? Well, we want to make it smaller. And so here's where our negative numbers come in again. We're going to say change the x by negative 10. And changing by negative 10 means subtract 10. So whatever the x is of our cat, we're going to subtract 10. Okay, and just by doing these two statements, I can just start using them right away. When I press the right arrow, the cat goes to the right. Here I am, click, 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 click on the right arrow. And then when I press the left arrow, the cat goes to the left. Click, click, click on the left arrow, goes to the left. Okay, so those already move the cat, and that's great. Let me go ahead and do the Y ones. Before I do that, I'm going to go ahead and go back to my stage and go back to the backdrops and just switch back. Instead of showing this XY grid, I'm going to just show my maze again. So nothing changed. I'm just showing the maze. I can show the XY grid, show the maze, show the grid, show the maze. They're just two different backdrops that are part of my stage. It's called in Scratch. So let me click on the cat again to go back to its code. I'll click on the code again. And and you can see here the cat still moves. Left arrow and right arrow move the cat still. Notice he walks right through the wall. We're going to talk about that. But let's go ahead and finish it by doing the Y coordinates. So we're going to say when the up arrow is pressed, right, we want to change the Y. And the question is, when you're trying to go up, do you want to change the Y by making it bigger or do you want to change it by making it smaller? And so the way the coordinates work is that up means bigger. So we want to change the Y by 10 and that'll move the cat up. So here I go up, 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 and it moves up. My down arrow isn't working yet. So when I click that, it's not working yet, but I'll go ahead and add that now. When the down arrow is pressed, and I'll go ahead and right click on this thing, duplicate it, and put it right there. So when the down arrow is pressed, what do we want to do? Same idea. Now we want to subtract from the Y by 10. So we're going to use our negative numbers and say change Y by negative 10. Okay, so that will change the y by -10. So now that I've done that, I have all 4 keys working. I can move the cat left and right, up and down, and it'll move all over the board like this, just with those 4 keys. Okay, and you can see as I click each one, it kind of flashes to show you which of the codes, which code is running. Okay, which of those event handlers, the programmers say, which of those event handlers is running when the keys are pressed, when the different keys are pressed. Okay, so I have 4 when key pressed, I have 4 event handlers. And actually the when green flag click, that's also an event handler. It's the event being clicking on the green flag. So this program now has 5 event handlers. Okay, so let me talk now about what I said before about the difference between using if right arrow pressed versus using the when right arrow key pressed, like we're doing here. And the difference is that when you use the when, like we're doing now, you can have a little bit of a problem with repeating keys. Okay, so if I just tap the key right, it works. If I click the key and hold down, what happens is that it moves and then it takes a little bit of a delay and then it starts repeating. Okay, so I'll show you that again. When I click, I'll tell you when I press it down. So I go down and then it goes down and then it goes. And the same thing, like if I press the down arrow, I click the key and then it goes. Here's the up arrow. I click the arrow and then it goes. So it does one and then it waits a little bit and then it starts repeating. And the reason it's doing that, if you look up here in the top of the window, I'm going to just sort of type some characters here in the URL part of the window. And so let me just type like an M. So M, 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 that just works like normal, like when you type the letters. But what happens when you hold the M key down? Well, if I click it and hold it down, it types one M and then it waits a bit and then it starts repeating. So here's the first M and then it repeats. Okay, and I'll do it again. Here's the first M and then it repeats. So a little bit of a delay. And of course, that's because when people are typing on the keyboard, you don't want the key to start repeating until they hold it down for a little while to show that they want it to repeat. But we're sort of having the same thing happen in our game when we press the keys, because that's just how the computer is working with the keys. So in this particular case, it's not that big a deal. It's probably fine if the player presses the key and then it starts repeating when they're playing this maze game. In fact, they may not even ever repeat it. They may just tap each one, key, like that to play the game. But when we were playing our racing game where you had to turn left and right and you wanted it to turn as soon as you press the key and you wanted it to keep turning, it wouldn't have been any good if it kept having this delay where it stopped turning and then it started turning again. It would have felt like the game's not fair, like it's broken. So we couldn't have used these when key pressed for that. And that's why we had to use the forever loop with the if key pressed, okay? So in this particular game, we don't need the forever loop, but even in this game, if we added some extra stuff to the game, which we'll see later, we're probably going to want to put the forever loop back in. So I still, maintain that the forever loop is a good thing to always think about. Every game has an initialization and a forever loop. And in fact, you can kind of think of it that like when this game starts, it does the initialization. And then the forever loop is kind of just like Scratch sitting there waiting for us to press one of those keys. So it's a little bit like Scratch is doing the forever loop for us. You can think of it that way. Okay, so anyway, but I'll go ahead and throw this out now because we're not going to use this kind of key thing for this game. Okay, we're going to use these. All right, so the next thing to talk about in this game is what happens when we walk through the wall. And right now, when you walk through the wall, it just goes straight through the wall. So I want to show you how we can fix that. And we want to think about, okay, well, how do we fix that? You know, like how do you... How are we going to check whether when the sprite walks through the wall, and especially not just check, but how are we going to make it so the sprite doesn't walk through the wall, can't walk through the wall? All right. Well, As you know from our previous project with the basic racer, remember when the cat went onto the green, we slowed it down, and we did that by using one of these sensing blocks, and we used the touching color. Okay, so we kind of know that we're probably going to use a touching color because that's, we're going to say if we're touching the purple color, that means we've hit a wall. So let me go ahead and just make this the purple color first, and I can do that by clicking down on this color, and then I can click down on the icon here, the eyedropper icon, and then I can go over to my game and I can just click anywhere on the purple. All right, and by doing that, it changes this block to have purple in there. Okay, so now it says touching color purple. All right, but we don't just want to say touching color purple, we want to say if touching color purple. So let's go get an if block out. All right, I'm going to just keep the forever loop on the side there. And I'm going to make this if statement, and I'm going to put the touching color purple right here in this block. Okay, so if touching color purple. And now the question is, what do I want to do if I am touching the color purple? Okay, and to make it sort of simpler, let's just think of this one case of going with the right arrow. Okay, and the question is, what happens when I press the right arrow and I change X by 10, and then I check if I'm touching the color purple? All right, so what I want to do is I want to think of it this way. The cat's going to walk towards the wall, and then at one point, when I move to the right, the cat's going to kind of like be touching the color purple. It's going to be in the wall. It's going to be touching the wall. And at that point, I want to say, uh-oh, we hit a wall, and I want to fix it. So I want to make it so that the cat isn't in the wall anymore. All right. So for this particular case, when you press the right arrow, you change the X by 10. So we go 10 spaces to the right, and then we check, okay, am I touching the color purple? And if I am, what do I want to do to sort of fix it? Okay, and if you think about it, well, if we change the X by 10 to get into the wall, if we change the X by -10, it'll pop us back out of the wall, back to where we were. Okay, so what I can do is I can actually take this change X by -10 right here, click on it, right click on it, duplicate it, and put one right in there. Okay, so now it says change X by 10, and if touching color purple, change X by -10. So let's just see how that works. I'm going to back up so we can see I'm going left, 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 and then I'm going to go right, 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 and I'm going to go, and now I'm pressing the right arrow over and over again, and you actually see the code flashing, which shows that this code is running, but we see that the cat doesn't get to go through the wall. So it's working, but if you think about it, it's a little strange, because remember how we did it? We did it by saying, well, first change the X by 10, which is going to put the cat inside the wall, okay? And then we're going to check, oh, are we touching the color purple? If so, change the X by -10 to take the cat out of the wall. But when I press the key, the right arrow here, we don't see the cat going into the wall and out of the wall. The cat is just sitting there. And the reason for that is that Scratch is pretty fast, and it actually does this whole block of code before it ever shows you anything changing on the screen. So it actually moves the cat into the wall, checks if it's touching the color purple, and then moves the cat back before you ever see it. Okay, so that is a little bit of a tricky thing to think about. But one thing we can do to make it to see what's going on is to go to our look section, and remember we saw this little block say hello for 2 seconds. So what I'm going to do is I'm going to stick that hello for 2 seconds right in there. Okay, so look at what the code says now. It says when the right arrow is pressed, change X by 10. Then if I'm touching the color purple, then do 2 things. The first thing is you say hello for 2 seconds. And the second thing is then you change the X by -10 to pop back out of the wall. So this time, watch what happens when I press the right arrow key. I press it, the cat is in the wall and says hello for 2 seconds, and then the cat when it's done saying hello, it pops back and says, and pops back and out of the wall. So here I'll do it again. Press, says hello for 2 seconds, and then it pops out of the wall. So by putting in this say hello for 2 seconds right in here in the code, we could debug our program. So it's a debugging technique. It's a way to slow the program down so that we can see what's going on. Okay, and now that we understand what's going on, we can go ahead and just take it out. So I'll take out the hello and put it here. All right, so what I want you to do now, we've made it so that the cat can't go through the wall when it's going to the right, but the cat can still go through walls when it's going to the left. It still goes straight through the walls when it's going to the left. And it also still goes through walls when it's going down. It'll go down straight through the walls. And when we go up, it'll go straight through the walls, all right? And of course, the reason it's doing that is because these event handlers right here don't yet have anything about if I'm touching the color purple and undo it. So what if you're following along with the code, which you may be, or you may be just watching, but one thing you could do is go and do the project now up to this point, and then try to figure out what if statements exactly do you have to add to these other blocks to make them do what this first block is doing. So I'll give you a second to do that. You can pause the video, and then when you come back, I'll show you how to do it. Okay. So let me show you how to make these blocks work, and it's pretty simple. Like with the right arrow, we can copy this one out, duplicate it, and stick it on the left arrow. All right, and let's just think about what's different here. The left arrow says when you press the key, I change the X by -10 as a way of moving to the left, and then if I'm touching the color purple, then I want to undo that by moving to the right. So to move to the right, and we're just going to take the negative off the 10 because now we want to add to our X coordinate instead of subtracting. Okay, so let's see if that works now. Here I am, I'm moving to the right, can't move through the wall, and here I am moving to the left, and I can't move through the wall. So that worked great. And let's do a similar thing with our Y blocks, okay? So when I press the up arrow, so if the up arrow is pressed, I change the Y by 10, so I go up, and if I've hit a wall above, then I need to come down to correct it. So I'll throw away this block, and I'll use the change Y by block, and I'll say if I change the Y by 10 to go up into the wall, I want to change by -10 to go down out of the wall. All right, so I'm going to do that like that. All right, and then let's do the last one with the down arrow and duplicate it and say, okay, if I've gone down by changing the Y by -10, then I need to fix it by going up and changing the Y by 10. So I just get rid of this minus sign on that one and just put in 10, and then that should work. So let's move the cat around. Okay, can't move through that wall, can't move through that wall. Can it go down? Nope, can't go down through the wall. Can it go up? Nope, can't go up through a wall. So now we have the whole game working where you can move the cat around and it blocks it when it tries to go through a wall. So that's a whole maze game, and then eventually we can go through here and walk out of the maze. All right, so that's the main code for the maze. We have these 4 blocks like this that handle all the different directions that we can move. And then we have our initialization code, and that's it. If you go back to the project, there's a few challenges for you to do after that. And one of the challenges is to check if the cat has won, so you can like say congratulations to the player, or the cat can say I won. And so to say I won, we're going to use that same thing here where we're going to say, like, instead of saying hello, we're just going to type in I won with an exclamation mark. So we want the cat, when it gets over here, to say I won, like that on the screen. Okay, so The question is, how are we going to do that? How are we going to know when the cat is over here and saying, I won? Right, okay. So let me, there's a few different ways that you can do this, but one way we can do it is to add another sprite to the game, okay? So let's go ahead and choose another sprite, which is going to be like the goal that the cat is going to try to get to. So let's use like the apple. Here's the apple, all right? And let's do the same thing with the apple where we say when the game starts, or we go to the when they press the green flag, I want to change my size to a smaller size. So let's say we can set the size to, and let's choose a good size for the apple, maybe 30%, and click on this. Okay, that seems like a good size, and I'm going to put the apple right there. And if I want to be even fancier, I can go back here and get my go to XY again. So that's the initialization code for the apple. And that means that if for whatever reason the apple was ever over here, when the game starts, the cat goes over here and the apple goes over here. Even though in this game, the apple's not really going to move. But if it did, it's nice to have the initialization code so it always goes back to its place at the start. Okay, so we got the apple. Now we're going to go back to the cat, and I'm going to shrink the code just a little bit because we're going to need a little bit more space. Let's see if I can do that. So we have all of our event handlers here handling the different keys, okay? And then we have this thing, say I won for 2 seconds, but we only want to say I won when it's touching the apple. So if we go back down to our sensing, we see that there's this touching block, and instead of saying touching mouse pointer, we can say touching the apple sprite. Okay, all the other sprites are listed here, in this case the apple, so we can say if I'm touching the apple, that's when I say I won. All right, so let me go here and say if I'm touching the apple, say I won for 2 seconds. All right, now here I'm going to just show you one more thing. I'm going to go ahead and get rid of this forever loop for right now just to make some space. I'm going to show you one more thing that often confuses people, and this is the thing. Well, first of all, let me show you this block working. So let me just show you that when the cat is not touching the apple and I click this block to make it go, okay, it says if I'm touching the apple, say I won. Okay, well, the cat's not touching the apple, so it doesn't say I won. If I put the cat so it is touching the apple, then when I click this block, the cat says I won. All right, so we see that that block works. Okay, the block works, but the question is, where should we put this block in our whole program to make sure it's going to get checked at the right time? And so here's the mistake that a lot of people made. I've seen lots and lots of kids do this, and so I'm going to try to explain why it doesn't work. And what they do is they put this if touching apple right there on their in their code, okay? And they say, well, I did the right thing because I initialize the program, and then I have this rule, and the rule says if you're touching the apple, say I won. All right, but if we actually play the game and move the cat around, you'll see that that doesn't work. I go down here, I go over here, and then the cat goes, it touches the apple, and it doesn't say I won when it touches the apple. And the reason is that if you think about it, what are we really saying here with when the green flag is clicked? Okay, what are we really saying? Well, we're saying when they click the green flag, do this, then do this, then do this. So the first thing is to set the size, the second thing is to go to a position, and the third thing is to do this if statement. And so what happens is when I press the green flag, it sets the size to 20%, it goes to this position right here, its starting position, and then it does this statement. It says, if I'm touching the apple, which I'm not, so I don't do this, and then I'm done. So then we're all done with the when green flag click block. It's done, and we're never going to come back and check this again because it already did the things that we said to do, right? So one way to do that, and this is where that forever loop would come back in, if we had a forever loop and we put this in, Then what this says is keep checking, keep checking, keep checking if you're touching the apple. And that would make it work. So when I go over here and play the game and go all the way to the apple, okay, and you can see this time that this whole block is still lit up in yellow, okay, it's still highlighted in yellow, and that means that it's still running. And the reason it's running is because we put in that forever loop, so it's checking, 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 and it's doing all that. So when I touch the apple now, it says I won, all right, and that's good. But there's a problem. You can see that it just sits there and says I won, and it doesn't go away, even though we said say I won for 2 seconds. And the reason is that the forever loop keeps checking and checking and checking, and it keeps saying, yep, you're touching the apple, say I won for 2 seconds. Yep, you're touching the apple, say I won for 2 seconds. So it's going to keep doing that over and over again. So in this particular case, we could fix that. But in this case, let's not use the forever loop. Let's take this out. Let's take the forever loop out. Okay, and let's do it a different way. So let's say this is our initialization code. And instead, I'm going to show you one more thing about Scratch, which is important, which is that there's this idea that you can make a block of your own. Okay, so if you click this purple thing down here, okay, there's a button up here that says make a block, all right? And then when you click that, it says, what do you want to name the block? And I often use names, you can call it whatever you want, but I use names that start with the word check. So we're going to say check if one or something like that. Check if one. And we're not going to worry about these other things. Those are sort of fancier for later. We'll talk about those. So we just say, okay, make a block. And what we did is we made our own block that says check if one. And what I'm going to do is I'm going to hook this check to see if they've won, to see if they're touching the apple. I'm going to hook that up right there. So that's what check if one means, all right? And then the idea is that since we made this block, we can now use that block other places in our program, all right? So here's the block, it's called check if one, and then wherever we want to do this in the program, we can use this block right here to do this code, to do the check if one code. So in other programming languages, this is called a function, and then when we use the function somewhere else in the program, that's called calling the function. So we wrote a function, and now we got to figure out where we need to call the function to do the right thing. And if you think about it, the answer is that a good place to call the function is right after we make a move, okay? So for instance, if you move up, we change the Y and maybe we back out of the wall, but either way, when we're done, we can check if you've won. And similarly, when you move with the left arrow, right after we do that, we can check if you've won. And similarly with the down arrow, right after we do that, we can check if you've won. And with the right arrow, we can check if you've won, all right? So I could have taken this block here, this big block, and put it on all my other blocks instead of doing this check if one thing. But the nice thing about check if one is that I only have to write it once, and then I can use it in all these different places. And every place where it gets to check if one, the computer goes down here and does whatever code is in my check if one. All right, so let me just show you that. We go here, 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 and we're going to touch the apple, and it says I won, and then it goes away after 2 seconds. So it only did the check if one, one time. It wasn't stuck in that forever loop like before. So So what I've shown you in this, which is a thing that you don't often learn about until later in Scratch, but I think is important to learn about early, is the idea of defining your own blocks and using the block you defined in different places in your program so that you don't have to write code in multiple places, write the same code in multiple places in your program. All right, so that's the complete program. On the webpage, scratchcats.org, under the Maze project, there's some other challenges. So that this is the one we just did about checking to see if you've won. And some of the other ideas are to have some things that you're not supposed to touch, and a portal, and a robot. So the idea of those challenges is that the things that you're not supposed to touch is that maybe there's some other sprite, like a flying saucer, that's moving all around the board. And whenever it touches the cat, it sends the cat back to its starting position. All right. And that's definitely going to be one where probably you're going to want to use that forever loop in there to check if the cat is touching the flying saucer or whatever you make, and it goes back to its starting position. So that but that would also require making the flying saucer as a different sprite. So you'd have to add another sprite for that. And then the other idea was the portal idea, which is like if you go down and you touch some other sprite here, it would like jump you over to another place in the maze or something like that. So and to do that, to move you over, you would want to use this go to XY again, right? To jump you over to whatever place you want to jump them. So those were just two ideas that you can try. If you wanted a real challenge, the harder challenge was to make the cat move automatically. So instead of having the player move the cat, have the computer move the cat by like moving until it hits a wall, and then choosing another direction, and then like moving until it hits a wall, and then moving until it hits a wall, and then moving until it hits a wall, moving until it hits a wall, moving until it hits a wall. So that's an advanced one, and that might be one that as you learn more about Scratch, you can think more about how to do that. But one thing that is worth saying is that, it's not like one kind of game or one kind of project is like an easy project or a hard project. I mean, some games it's hard to just make the game work at all. But a lot of times you can start with a very simple project like a maze, and then you can do all sorts of complicated things that even, a college student, studying programming might not be able to do very easily. So, I always think it's good to make a project and then keep going back to it and see like, okay, what could I add to that? How could I make that project fancier? You might have an idea. Oh, maybe the cat could move automatically through the maze. How would I do that? Another idea that you might try. Remember, we talked about how it's kind of a pain to draw the maze like this, and it's really hard to get it perfect, but maybe you could have a thing where the computer draws the maze for you. Okay, so that's a challenge to think about later, where the computer could draw a perfect maze for you. So anyway, you can ask me about those things when we're online together if you have any questions about those. Okay, so that's the maze project, and I will record another one soon. I think I'm going to do the platformer next. Let me know when we talk if you have any questions about the maze project, and otherwise I will talk to you soon. Okay, goodbye.